Hello everyone. In this video, I'm gonna represent another example of Taylor series expansion and talk more about their remainder term or truncation error for specific function. So let's assume our function is ln x, and we want to expand this function at x0, 1 in interval between 1 and 2. So let's write the Taylor series expansion formula. We know the summation for, and that will be x minus x0 power of k factorial, and k derivative of function at point x0 plus Rn x, which where Rn is x minus x0 power of n plus 1 factorial derivative of f plus 1 at psi. So psi is unknown. Okay, let's compute the derivative of f for function ln x. The derivative, the first derivative of function ln x is 1 over x. The second derivative 2 is minus 1 over x squared. So we know that we compute derivative at x0. So it means that it should be 1 over x0, or here it should be minus 1 over x0. And the third derivative 2 over. So if you keep doing these, you will see that fk will be minus 1, k minus 1, k minus 1 factorial, and x 0 power of k. So it means that fk for this function given x0 is 1. So fk will be minus 1, k minus 1, and k minus 1 factorial. So this will be fk for this function. Note that this will be 1 because x0 is 1. Now we can say that ln x is a0 in x minus 1 power of k, k factorial minus 1, k minus 1, k minus 1 factorial. So we know that k minus 1 factorial over k factorial is 1 over k. Therefore, it can be simplified as minus 1 k minus 1 k minus 1 over k plus Rn x. So let's see and simplify this expansion. Don't forget to write summation. Okay, that will be x minus 1 minus 1 over 2 x minus 1 power of 2 plus 1 over 3 x minus 1 power of 3 minus 1 over 4 x minus 1 power of 4 plus, what is the last term? Minus 1 power of n minus 1 x minus 1 power of n over n plus Rn. Okay, so this is the Taylor series expansion of ln x. Now I want to talk more about Rn x. So I gave you the formula for Rn. Let's write it here. X minus 1 n plus 1 over n plus 1 factorial times. So what is the derivative of function at psi? So here k is n plus 1, which means minus 1 in n factorial, and there is psi, because this was the original formula for fk, because here we compute derivative at psi, but here we compute derivative at x0, which was 1. But here the point is not 1, that's the unknown psi. So at the bottom would be psi power of k, which will be psi power of n plus 1. If we summarize, we see that minus 1n psi power of minus n plus 1 over n plus 1, because n factorial, this one just n remains, and x minus 1 power of n plus 1. So this is Rn. Now the question is, what is the upper bound of Rn with accuracy of one part in 10 power of 8. So how to solve this one? So we know that psi is greater than 1. Why? Because psi will be in this interval as well. So we know that psi will be greater than 1. Therefore, psi power of minus n plus 1 will be less than 1. That will help us to find the upper bound of truncation error. Okay, so Rnx was minus n plus 1 over n plus 1, x minus 1 n plus 1. That will be less than n plus 1. When I correct this, there's an absolute here. It's minus 1 and plus 1. So we need Rn. So what is the upper bound of truncation error. What is the upper bound of truncation error? With accuracy of 1 part in 10 power of 8 in computing ln2. So Rn2 less than 1 over n plus 1 to minus 1 n plus 1 should be less than 1 over 10 power of 8. So if you simplify, you see that n plus 1 should be greater than 10 power of 8. So what is the similar step, similar process for ln 1.5? So Rn 1.5 should be less than 1 over 10 power of 8, which means that Rn 1.5 should be less than 1 plus 1, 1.5 minus 1, and plus 1, 10 power of 8. So if you simplify, you see that n is, so what is the point here? The point here is you see this, you will reach to the same accuracy with only 22 terms at 1.5. Why? Because your Taylor series expansion is around 1. It means whatever you go away from this point, you have more, or let's say large truncation error. Whatever your distance is larger than 0, you have larger truncation error. So in order to get the same accuracy, you need more terms. As you see here, you really need a huge number of terms to get that accuracy. But here it was just 22 because 1.5 is closer to 1. I hope this video was useful for you, and thanks for watching.